Hello Internet, welcome back to our binary clock. This is going to be a short episode, and what we're going to be focusing on is we are going to be focusing on converting a single integer value into the binary or the Boolean array that we need. So we're going to convert from an int into this little structure here. So the idea is we can plug in any number and it should be able to be represented here. So this is where we're at, and let's see where we're going. To start with, I think we should just be able to... Technically, we're creating a converter. I'm not going to inherit the converter class. We're actually going to be... It just is going to be a C# class, but we can put it in with the rest of our converters, and it's going to be an integer to Boolean array converter. And so once it finishes, there we go. I think we can make this static. So there's just going to be one method here, and it's going to return a Boolean array, and we are going to do convert to bools. And it'll take an int of our value. And so what we need to do is we need to convert our value into some sort of Boolean array. The easiest way to do this is with a list of bools. So we're just going to store a list of Boolean values. I'll call it our list. That sounds like a all right. I feel like that's an alright name. I don't. At the same time, I don't like it, but I think it works. So then all we need to do is return our list as an array. And so this toArray function is going to convert our list into an actual array, and then we can just go from there. And toArray, I believe, is an extension method coming from link, but I could be wrong there. Nope, looks like it's always there. If you delete the namespace and it still works, then it's clearly not coming from there. So, well, actually there's an easier way to find this. We can actually go to it. Looks like it's defined actually in the list. Yeah. Cool. Okay, so it's part of the list that we're using. So anyway, that was a tangent we didn't really need to go down. But all we need to do now is take a integer value and build our Boolean array. And so it's important to remember that the first value is actually going to be our most significant bit. It's going to be our biggest bit. So we want everything to be added to the front. And when I say that, the way we're going to be doing this is we are actually going to accept two values here. We're going to accept a length as well. And so how this is going to work is for the index of I equal to 0, and while I is less than the length, we're going to do that many steps. So we're going to do however many steps are defined in this length. That's how many we want to do. It doesn't really make any sense if this is above like 32. If it's longer than the total bits of in an int, it's gonna not really make any sense. But we can still work with it. And so how we're going to do this is we're actually just going to do some really simple logic here. So if we take our value and shift it left or shift it right I times, which means we're shifting it I bits to the right, then we can also compare it and see if it's equal to 1. So if it's equal to 1, then it's true, and that will be our value. So we can have a variable here called our result. And that's actually not what we want to do. We also, this is going to get a little complicated, we want to AND it with 1? No, because is it 1? Will 1 work? 1 should work. Yeah. I think that makes sense. it's really not going to like this. So we're going to have to do that. It's still not liking it. Because order of operations, the equal is going to happen first. Okay, now let's walk through what this is going to do. First, it's going to take, it's going to do a right shift. So actually, sorry, yeah, it's going to do a right shift, which means it's going to lower the numbers. The easiest way to think of this is it's kind of dividing it by 2. That's sort of the same thing it accomplishes, but it actually does a little bit more than that. All you're doing is you're taking your binary, your bit string, and you're shifting every value in it to the right, and you just keep going. It might look a little bit weird on the camera because I flip it. But anyway, you're going to shift it over. And so we're shifting it over I positions, which means the first time it's going to not be shifted at all. And then we're going to do a binary AND, a bitwise AND, with 1, which means we're going to take the first bit in that string and say, is this that value? So the first time we're going to look at the first bit, and then the next time we're going to shift it over and look at the second bit and so forth, and just keep doing that over and over and saying if this is 1, then our value is true, otherwise it's false. And so theoretically this gets us the binary position at this position. That's what I'm thinking it's going to do. That was what I was thinking in my head, at least. Could be wrong. Kind of came up with that last bit on the spot, but we should be able to test this pretty easily. So what we need to do now is do a list dot, I think insert works. We want to insert at the 0th element and insert our result there. So we're always inserting things first into the first position instead of at the end. And that way, the most significant bit is the first element, because this is going to process from least significant bits to most significant bits, and it's going to always give you a length of the length that you give it. So even if we shift over like 100, for example, we're going to get 100 results. It's just everything after that 30-second bit is always going to be false because it's just going to keep putting zeros at the front of it. That's how this works. It's actually, so I think there's 2 shifts. C# may not like it. No. Okay. In C++, there's 2 different shifts. There's the logical and the arithmetic shift. Now I'm going to get it wrong which one is which, but one of them is going to shift over and append zeros, and one of them is actually going to wrap. So if there's a 1 at the lowest bit, and it shifts it off of the thing, it actually puts it in the front then. With C#, it always is just going to append that 0. So anyway, we have our list. It should be getting built, and we're returning a bunch of stuff. It really doesn't like this because we made a static class and a non-static function, which means there is no way we could have called that. Now we can. Cool. So that should get us what we need. And now all we need to do is go into our main view model. And instead of doing this fun thing, we can actually just call it. So we can do a Boolean or integer to Boolean, a Boolean array converter. And we're not getting it. There we go. Got it. Cool. And then we want to convert to bools. And we want to, let's see, this is the 3rd episode, so let's do 3. And we'll give it a length of 4. So we should see white or empty, empty, white, white is what we should see, because it's going to be 0011 as our binary string. So if we run this, assuming everything's working correctly, this should get us our correct binary. So let's see what happens. And if it explodes in our faces, then we'll work from there. Hopefully it doesn't. Yeah. Okay, so we are getting exactly what we wanted. We're getting 2 empties, and then we're getting white, white, which is 3. So that works. Just going to run a few more tests here just to make sure everything is going as planned. What's a good number? 15? Sure. So 15 is going to be, I think 6 should do it, because that's going to be 1, 2, 4, and 8 are the ones we want. 1, 2, 4, 8. So we're going to have, we need at least 5 bits, and so the first 2 are going to still be white, or at blank, and then the next 4 should be white. So if you're not familiar with how binary works, it's powers of 2. So the first bit here is going to be 1. The next one is 2. The next one is 4. Next one is 8. Next one's 16, and so forth. So everything below this is actually equal to 15. Everything below this would be equal to 31. This would be equal to 63, and it just keeps going up as powers of 2. It's the same. The way it works is exactly the same as the normal numbers you'd use every day. The only difference is those numbers are base 10, which means it's just powers of 10. So if you think about it, if you see 10, that's just 10 to the first power. If you see 100, that's 10 to the second power. If you see 1,000, that's 10 to the third, and it just keeps going up like that. So there's no difference here. We're just using, there's only 2 different values you can have instead of 10. That's the only difference. And any base number system is going to work like that. So hex does the same thing. It's just powers of 16. Anyway, this number system, or this converter rather, seems to be working. So we can plug in pretty much anything we need. So I'm going to plug in 16 here, which would do highlight that second from the top one. And if this works, I think I'm pretty comfortable that we're in a good position. If we start noticing weird behavior, then we can fix it later. But this seems to be doing what we needed. So I think we're in a good spot. So in the next video, we're actually going to use this to take the time. So we're going to take our seconds and our minutes and our hours, and we're actually going to convert that into binary using that formula we just created, and then actually put it and draw it on the screen. So that's coming hopefully tomorrow. So I guess that's it for this one. So if there's anything you guys want to say or anything you want me to add, let me know in the comments. If there's something you want me to improve, let me know about those as well. Other than that, I'll see you in the next one. So see you, Internet.